Right. It's exactly 5:30 now. We start the class here. Okay. So voice is audible now?
Yes, sir.
Okay, right. You move on. So first of all, I want to confirm one thing. You can inform to your friends also. For BW subject, no need to take any worries, and even no need to study any other material also. Generally, many students refer the spectrum before the examination, where you see different questions. So you'll be in a confused mode. So with full confidence, I can say, just following our notes and the syllabus copy. Every time you should have the syllabus copy with you. And meantime, we are going to repeat the previous year papers also, last year BW paper. Okay, so that is quite sufficient. So now today's class, what I am going to do, so the toughest topic I am going to pick up. We do take the problem also on that particular topic. So first, if you see the unit 2, Unit 2 is entirely AC current, okay, but one topic we have not taken in detail, okay, that means with problems we are supposed to take. So that topic is the three-phase balanced circuits, where the question, direct question, 100% external examination point of view I'm saying. So you will get the question from the second unit, essay question, derive the relationship between line and phase voltages for star and delta connection, relation between line voltage and phase voltage for star and delta connection. So this separate part will make you to clear the essay question, which is the 15 marks as per the new paper format we are going to discuss. Okay, so you might get this particular question. It is the 100% chances are for this one only. Okay, so we'll take that question directly, the explanation. Then we take in today's class only three-phase transformer connection. So these two are interrelated. So this is entirely diagrammatic part followed by this particular explanation. Okay. Then slowly we'll target the transformers, unit 3, the problems and whatever the questions you are going to get. Okay, right. So let me share the new slide of that particular, right, the topic. Now the topic name is relation between line and phase voltages for star and delta connected system. So I will bring the explanation as per the examination point of view in a short form. Okay. So what exactly you are supposed to put in the examination is represent here. So in a straightforward manner, so let us share this one. Three-phase system we are having. You can ask, sir, what is this three-phase? If you see any modern flats or else hospitals, even the movie theaters, hotels, everywhere we are using three-phase, even in the industries. Okay, what is advantage of three-phase? Why we have to use this word three-phase? Means phase means, what is phase? The wire which contains the energy is called phase. In your house also you are going to get two wires from your energy meter. In your house you are having the energy meter. From your energy meter you see you are going to get two wires. One will be red color, another one will be black color. So red color wire is called the phase wire, black color wire is called the neutral wire. So the wire which contains the energy is called phase wire. The wire which has zero energy is called the neutral wire. So in our house we are using single phase. You can also go for the three phase. Okay, what is advantage? Three phase system provides less electricity bill when compared with single phase. This is the first advantage. If you are using three phase system in your house, so even the electricity bill what you get with the maximum consumption of power will be less when compared with this single phase. That is one advantage. Three phase supply rotates heavy machines. Example, lift. Wherever you see the presence of lift, there you are having the three-phase supply. Okay. So three-phase system means it can be drawn in the shape of star or delta. So that's why, what is three-phase system? Three-phase system contains three different voltages which are displaced by an angle 120 degrees. Okay, this is the three-phase system. So which element will generate the three-phase energy? Synchronous generator, which we have studied. Okay, this is the basic introduction here. Now from where we have to pick up the topic? Our topic is relation between line and phase voltage for star and delta connection. Sir, show me the star connection practically. Yes, you are into the poles. If you see the poles which are placed in outskirt region, you will definitely see only 3 wires because we are using 3-phase system. 3-phase system says that 3-phase system has 3 different wires which are displaced by an angle 120 degrees. If I am not maintaining 120 degrees, I cannot generate 3 different voltages. Even engineers, they have done experiment with 180, 90 also. So at last, 3-phase system is used in every country. 3-phase system is used to run heavy machines. 3-phase system is used for all industrial applications. So 3-phase system, 3-phase supply or 3-phase system contains 3 different wires, and you can see that practically at the pole. Now you see the second one. Second image says that you are having 4 wires. Okay. So why you require another wire, extra wire? The new wire is called the neutral wire. So where we see this 3-phase 4-wire system near our house. So wherever number of houses are present, as the house requires only single phase 230 volts, we convert the 3-phase supply to single phase. Okay, and that single phase is given to your house. So why I'm showing these two means now our topic is related to this one. So now in detail, if you see, okay, transformer we have studied, you can see this is pole mounted transformer, lightweight transformer. This is the white color one is transformer. We have studied the fuses also. Here also we are having fuses. Okay. Now you see here they have mentioned hot, hot, hot and system neutral. So hot means phase wire. Another name of the phase is hot wire. So for common man understanding, they mention R by B. How many phases here? 3 phases. Phase 1, phase 2, phase 3. So certain times we might be having the power, our neighbors will not be having the power. That is, they are connected to different phase. So now we enter into the topic. So what is star definition? Star says that, star connection says that all the secondary ends are connected to the common point. If you see this third diagram, the wires, all the secondary ends are connected to the pole. So this connection is called the star. Okay, everywhere, all transmission lines, wherever you see the poles, there we are using the star connection system only. So this, why we require this one, now you will see in detail in the diagram. So how to start the explanation? Explain the relationship between star and delta, that line and phase voltage for star and delta. So first, immediately 3-phase or star or delta word, if you see in the question paper, you must draw this diagram. Simple. R, Y, B. Okay, so why it is extended here. What is the main difference between star connection and delta connection? Now you see, 3-phase system can be represented by star or delta. No need to have any separate notes. Listen the class and make a note of this one. 3-phase system can be represented by star connection or delta connection. Star connection is used for long distance transmission of power. Delta connection is used for short distance transmission of power. Star connection is used for high voltage transmission. Delta connection is used for low voltage transmission. So wherever we require to transfer low voltage, we go for the delta. Okay, right. So this is the main difference. Star connection has got neutral wire. Delta is not having the neutral wire. Okay. Now what is this neutral here? You can see. What is the identification? Just now I have shown you the pole. If you see the star, this is first end. Let us say this is 1, second end. All the secondary ends, you can see the B, let us say this is B. This will be B dash. If this is R, it will be R dash. If this is Y, it will be Y dash. All the secondary ends are connected to one common point in a star connection. If you see the pole also, you can see all the secondary ends are connected to the pole. It is called 100% star connection. Okay. So this is the simple diagram of the star. Sir, why you are not drawing the copper wire? Why you are showing here just like inductor means? If you see the pole also, inside that one you are having this particular curvature or rotations here. So copper wire should be twisted. This is the indication of the winding or copper wire. Okay. So star delta diagram you must write wherever you see the problem or any theory. 3-phase word if you see, you must draw. Star or delta if you see, you must draw the star. Okay, star or delta. Now, in order to start the explanation, in order to understand the explanation, now you see the same diagram, star and delta. So examination question will be like this. Derive the relationship between line and phase voltages for star connected system. Then you must draw this diagram first. No need to show 440 and 230. Only this diagram, simple star connected system. So star connected system contains three different windings or copper wires which are displaced by an angle 120 degrees. We have already studied, everything is used in the induction motor also, but this is the basic. Okay, so transmission lines near the poles, how many wires we are having? Basically 3 wires. If you want the very low voltages, we are going for extra 4th wire, which is called the neutral. Now you see, all of you, if I am having the industries, you can see this 440 volts is nothing but the line voltage. The voltage present between any two lines, any two phases, okay, is called the line voltage. So we can call R as line 1 and Y as line 2 and B as line 3. Okay, here it should be L3 here in the picture. So you can see this arrow mark here, green color, which is saying that it is indicated diagrammatically the voltage present between L2 and L3, or the voltage present between any two lines is called line voltage. The voltage present between any line and the neutral, you can see any line and neutral, it is called phase voltage. So what we do near the pole we are having 3 wires followed by 1 neutral wire. Okay, power wires. Don't check the internet wires, don't get confused. Power lines will be near your house, 100% 3 wires and 1 extra wire will be 4th wire. Today only you can check. Now between any lines we are having the line voltage which is 400 volts or 440 volts in India. We require only 230. So connect one line and one neutral. You can see this one. Line L2 is connected to one house here. Load 1 means house 1. L2 is connected to house 1 and neutral is also connected to house 1. Therefore they get the 230 volts. Okay. So how you are converting 440 to 230 is our derivation. So derive the relationship between line and phase voltages. Now you might have understood. What is the relation between line and phase voltage means how you are converting this 400 volts to 230 is the question. Okay. So star connected system contains 3 different windings which are displaced by an angle 120 degrees. Draw the diagram. If you want still extension, star connected system has 3 different voltages. 3 different voltages. Okay, so you can draw this diagram if you are confident. So what this diagram are saying, 3 different voltages means I will show you the names. We'll come back to this diagram. One voltage will start from this 0, which are displaced by an angle how much? 120. So you can see this red one is starting from 120. Second voltage will start from the 120. Third voltage will start from the 240. Okay, so you can draw this one happily whenever you see the question star connected system. So now we start the derivation. Our language, engineer's language is vector diagram language, remember. So no theory maximum. So one line theory, circuit diagram, and going for the vector diagram explanation. You see all of you. So this vector diagram we have to explain in the examination. Remember, star connection means representation is done by voltages. Delta connection means representation is done by the currents. So I'll explain how to draw this vector diagram. Better all students be ready with one white paper and pencil. Okay, right. Now you see we are going to start the explanation. So video recordings will be uploaded in the YouTube. That link also I will share in the group. No need to worry. But listen, any question is there, wherever you are not understanding, you can put the question now. So examination point of view, explain, derive the relation between. Now you see star connection. I told you, I have shown you 3 waveforms, right? Star connected system contains 3 different voltages which are displaced by an angle 120. What is the first voltage? VR equal to Vm sin omega t, which is starting from the origin. After 120 degrees, Vy is equal to Vm sin omega t minus 120. And next to 120, the third phase voltage, which is Vm sin omega t minus 240. You can write this one. No need to represent this one. Okay, don't get confused here. So you know Vm is instantaneous voltage. We have already done the basics. So these 3 equations you can write. if you still require. Okay, and next that graph you can show. Okay, circuit that the star connected system diagram, these three equations. Now we move to the vector diagram. Okay, entire explanation is in the form of vector. So everything, this one you will understand later on. Right. Now, star connected system contains, now we have to write the steps. Star connected system contains three different phase voltages which are displaced by an angle 120 degrees. That means you draw three different phase voltages, assuming they are as vectors which are displaced by an angle 120 degrees. You can see three voltages, phase voltages. So when we call phase, you can write here VPH, 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 or you can write VRN. The voltage present between line and neutral, R line and neutral, is called the phase voltage. So what is the first statement? Star connected system contains three different phase voltages which are displaced by an angle 120 degrees. Okay. Now let VRN, VYN and VBN be the phase voltages which are displaced by an angle 120 degrees. As it is, you have to write. Now our derivation is bringing the relation between line voltage and phase voltage. Now one formula. Line voltage is the vector combination of phase voltages. A line voltage is the vector combination of any two phase voltages. So I require line voltage. Okay, line voltage will be VRY or VRB or VBN between two lines. No N will be present between them. So what we do, second step here. First step is let VRN, VBN, VYN be the phase voltages which are displaced by an angle 120 degrees. Second step, start from the origin, draw 180 degrees vector to VYN vector. Start from origin, draw 180 degrees vector to VYN vector. You can see now the animation. 180 degrees vector is drawn, which is exactly opposite to this one. So we can write it as the minus VYN, or we can put it as VNY. Start from the origin, draw 180 degrees to draw a vector 180 degrees to VYN vector. Okay. Now the resultant of VRN and VNY obtains line voltage VRY. The resultant or the vector combination of VRN and VNY obtains one line voltage VRY. Line voltage is a vector combination of any two voltages. Now you can see here, what is VRY written here? VRY is the line voltage we are supposed to generate vectorally. So it is the vector combination of, here again it is printing mistake here, it should be VRN. All of you can make sure this point, it is VRN, both are. It is a vector combination of VRN plus minus of VYN. What is minus VYN? We can also put it as VNY. So line voltage VRY is the vector combination of VRN phase voltage plus VNY phase voltage. So how to show graphically? Examiner will see this vector diagram only. So start from VNY vector. Now next point. Start from VNY vector and draw a vector parallel to VRN. So I am just extending this one. Parallelogram level. Yes, you can see on animation. Start from VNY vector and draw a vector parallel to VRN. Similarly, start from VRN and draw a vector parallel to VNY. Draw a vector parallel to VNY. Okay. Now from the origin, the resultant, the point of intersection of these two vectors obtains the resultant vector, which is line. This is what we are supposed to draw in the examination. If you see any material, it will be entirely complicated, but this is what simple, and you can get the complete marks. The star connected system, wherever you see in the question paper, derive the relation between three-phase star connected system. First, immediately draw that star diagram, go for this vector diagram. Any doubt is there, you can ask. Okay, you can unmute and you can ask. Right. Now next part, we are supposed to show the derivation. So what is a parallelogram law of vectors formula? The resultant voltage is equal to square root of phase voltages V square plus 2 V into V cos angle will take. Now you see, what is the angle between VBN and VRN? It is 120. And what will be the angle between VNY and VRN? It will be 60. Now you can see, let us show the angles. 60 degrees and next it will be 30 degrees. That's it. Okay. Like this one you have to be perfect. Okay. 100% you will get this question from the second unit. Without this question, till now paper has not given to my knowledge. Okay. Right. Come on. So now we are supposed to prove the derivative part, bringing the relation between line and phase voltage. You can show, sir, this is line voltage, these are phase voltage, and we brought the relation. No, we have to bring in terms of the formula. Okay. Now you see, okay, these two are phase voltages. So what is the expression? VRY is equal to under root of VRN square plus VNY square plus 2 into VRN, VYN or VNY cos 60. Because of vector voltage between these two vectors is 60. So that will show you. So instead of V, we have written here E. You can put it as V. VRY is equal to square root of, what is the first phase voltage? V square NY plus V square RN. You can write RN plus 2 into these two vector voltages as it is cos 60. So what is cos 60 is 1 by 2. You can substitute here. All are phase voltages. At last we have tried RY is line voltage, RN and NY is phase voltage. So we must write line voltage equal to all our phase voltages E square PH, E square PH. Okay, this expression. Now you take common EPH. If you take common EPH, what's going to happen? 1 plus here 2 into this one, 0.5. So you are going to get square root of 3 square PH, which is equal to root 3 times the phase voltage. So remember, for star connected system, where you see the star connected system, sir, show me the star connected system is all transmission lines, the poles and wires, their technical name is called the star connected system. Okay, for star connected system, we are having line voltage and phase voltage. The voltage which we get to our house is called the phase voltage, RMS voltage, of course, it is phase. The voltage which is transferred to the industry is the line voltage. Okay, line voltage equal to root 3 times the phase voltage. Automatically no need to prove line current equal to phase current. 2 marks also remember. Star connected system means line voltage equal to root 3 times phase voltage, line current equal to phase current. Now, the question might be asked, here also we have written star connection, line voltage equal to root 3 times phase voltage. You will understand when we take the problem now. Now, derivation can be asked. Relation between line current and phase current. Delta means currents. Star means voltages, relation. The question, if you are not getting star connected system derivation, you will get delta system. Derive the relation between line currents and phase currents for delta connected system. So how to explain? Same explanation, okay, just replace voltage by current. This is what you have to remember. No need to study any textbook. Same derivation as it is. Wherever you are writing V, you just replace by I. That's all. Remaining R by Rn, everything is same. So for delta, it will be reverse. Line current equal to root 3 times phase current. Okay. I hope everyone are understanding. So for star, wherever you put the voltage, replace it by the current. This is a short method. Okay. So line current equal to root 3 times phase current. If you do that, you will get line current equal to root 3 times phase current and line voltage equal to phase voltage. So delta, where we are seeing the delta connection, we see inside the induction motor. The connection is nothing but delta. Okay. Now we'll take the problem. You will understand. All of you, just better you listen this particular problem. Derivation is this one. Now, yes, if the paper is tough, problem will come. Problem with careful. This is the easiest problems here after derivation. If you understand this three phase can be drawn in the shape of star or delta. Star connection system, line voltage equal to root 3 times phase voltage. Now you see all of you. 3 chokes. 3 chokes means we can say 3 inductors in an house, 3 tube lights in an house. 3 chokes each of resistance 40 and reactance. We already know the reactance are connected in star. Any problem, if you see the word star, immediately write the formula. What is the formula for the star? Line voltage VL is equal to root 3 times the phase voltage. For star connection, line voltage equal to root 3 times the phase voltage. 1 second. Is the voice is audible? Anyone student confirm?
Yes,
Okay,
sir.
okay, good, good. Right. Now, in the problem, if you see the star word, you immediately write the formula. Line voltage equal to root 3 times phase voltage. Connected to three phase, 440 volts. Okay. So that means three tube lights are connected to the poles where the voltage is 440. Now you are supposed to calculate the line current, total power dissipated. Okay. Now write the given quantities: resistor 40 ohms, resistance, reactance 30. What is the formula for impedance? Impedance is the total opposition to the AC current. Impedance is the square root of R square plus X square. We have done in that second unit the formulas. Z is equal to root of R square plus X square. Okay, directly. So we have already done Z is equal to R plus JX, R minus JX if you are having capacitor. So here Z is equal to root of R square plus X square. You can do this one 50. Now, in the question, when they mention 400 volts or 440 volts directly, it is always assume it is line voltage. If I am saying 100 volts here, it is also called as line voltage. The voltage present between any two lines, any between, that means R and Y. Between R and Y, that voltage is line voltage. Between R and neutral point, it is called phase voltage. If in the question they are giving phase voltage, they will represent the word 440 phase voltage. Okay, if they are not representing, it is 100% line voltage. So these are the given quantities. In star connected system, what is the relation we are having? Line voltage equal to root 3 times phase voltage. So phase voltage equal to line voltage by root 3. Phase voltage formula. Only one formula: star line voltage equal to root 3 times phase voltage. Now we require, they are asking whether they are asking line current or power. First we have to calculate phase voltage and phase current. Any problem, phase voltage and phase current we have to calculate. So phase voltage equal to line voltage by root 3 for star, as they have mentioned star, which is equal to 440 by root 3, 254.4. So now here you can understand between those three lines we are having the voltage 440, and if you are connecting for one house, one phase and one neutral, it automatically converts to 250. You can do 400 by root 3. If you do 400 by root 3 in your calc, you will get 230.94. That is the voltage we are getting to your house. Okay. So phase voltage we have calculated. Phase current we require. So current formula I is equal to V by Z. Phase current means phase voltage by Z, not line voltage by Z. Okay. So phase current equal to phase voltage by Z. You are going to get this one. So in star connected system, line current equal to phase current. This is the answer. Okay. So problem, if they are asking, direct formula substitution only. So now I take you to the different set of problems. I'll share that that material also, all problems which are solved. Let me share to take one more problem. With calc, you can practice this one now. Okay, three loads, all of you, three tube lights you can say, each of resistance, that is resistor load. Okay, I hope the data is visible to everyone, right? Each of resistance 30. That means three different loads, three tube lights or three resistor loads, three bulbs are connected in star. So one question I'm telling, if I'm giving you two wires, you can connect them in series or parallel. But if I'm asking, if I'm giving you three wires at a time and asking to connect the three wires at a time, you cannot connect three wires in series or parallel at a time. You can connect them in star or delta. That's why the problems are different. If two wires are given, it can be done in series and parallel. Now, three loads, each of resistance 30 ohms are connected in star. By the time you see the word star, what is the formula? Line voltage equal to root 3 times the phase voltage. And what is the line voltage? Here they have not mentioned phase word. So it is 3 phase 415 volts. Calculate the system phase voltage, phase current, line current. So what is the thing here, all of you? Phase line voltage is 415. Here for star connection, line voltage equal to root 3 times phase voltage. Phase voltage equal to line voltage by root 3, 415 by root 3. You are going to get the phase voltage. Immediately, what is phase current? Phase current equal to phase voltage by impedance. But here impedance is not given in this problem, only resistance. So phase voltage by, what is the resistance given? 30. You can put directly 30. You will get this phase current. Okay. And for star connection, line current equal to phase current. So therefore answer is same. Okay, so I'll just post this particular material. You can see and practice, but we'll discuss this one. Now, you see three identical coils Again, tubelets, you can say each of resistance 10 ohms and inductance is given. Whenever inductance is given, immediately you have to convert that inductance into XL. Okay, inductor value should be converted into XL. XL formula, everybody know. What is the formula for XL? 2 pi F into L. XC formula, anyone tell me? What is the formula for XC? Capacitor reactance?
1 by 2 pi
Very good.
XC.
Very good. 1 by 2 pi FC. Okay. That's why I can confidently say all the explanations you will remember for your lifetime. Right. XL equal to 2 pi F into L. Substitute XL, you will get what is the impedance? Z is equal to root of R square plus now XL square. Z is equal to root of R square plus XL square. You will get the impedance. Any problem, what we have to calculate? In star they have given case 1. And what they are asking you to calculate? Power. But before calculating power, we have to calculate phase voltage. Next, phase current. Now you see, you got the impedance. Line voltage is 415. Phase voltage we have to calculate. What is the phase voltage formula for star? Delta, it is different. For star, it is phase voltage equal to line voltage by root 3 or line voltage equal to root 3 times phase voltage. You are going to get the phase voltage. The voltage present between any line and neutral. So similarly, what is the formula for phase current? Phase voltage by impedance. You are going to get phase current. For star, line current equal to phase current. Okay, this finishes. Now, if you want to calculate power factor says that quality of power transferred from poles to your house. Quality of power transferred from one place to another place. So power factor formula R by Z. Resistance to impedance. We got number of formulas. We can take a resistance to impedance. Resistance is given. Impedance, you know, you can directly divide. You will get this one. So in three-phase system, what is the power? AC power formula? Anyone? VI cos theta. DC power means V into I. But in star connection, as we are representing line voltages, remember directly root 3 VL IL cos theta. That means I can write three-phase power P is equal to 3 into V phase I phase cos theta. Formula is P is equal to 3 into V phase I phase cos theta. As we are converting, what is the phase voltage? Phase voltage equal to line voltage by root 3. If you substitute here root 3 into root 3 is 3. That 3 get cancelled, or you can remember directly P is equal to root 3 VL IL cos theta. I'll explain once again. Sir, how you are writing P is equal to root 3 VL IL cos theta? Actually, power, three-phase power formula is P is equal to 3 into VI cos theta. Okay. But what we have tried 3 into V phase I phase cos theta. That is the formula. So I'll write here. So P is equal to 3 into V phase I phase cos theta. Okay, cos theta. But what is phase voltage? Anyone tell me for star connected system? Phase voltage equal to line voltage by root 3. So root 3 into root 3 is 3. Therefore, we are getting this one. So power formula, you must write this one, root 3 into line voltage and line current and followed by cos theta. You will get the power dissipated. Okay. Or you can use this formula 3 into I square R phase current. You will get the same value. Okay. But use the first one. Okay. Now, how to solve the delta here? The second bit is delta they have given. Delta, when I will explain in the next class also. For delta, what is the change? All of you. Line voltage equal to phase voltage, but line current equal to root 3 times the phase current. Delta only formula changes. For delta connection, line current equal to root 3 times phase current, but for star, line voltage equal to root 3 times phase. The same process here. Cos theta, everything will be same. First you calculate phase voltage. IP is equal to VP by ZP, and you are going to get the line current. Okay, the power value will be different. So just practice these two. Remaining problems I will discuss later on. But now I want to take the three-phase transformer connection from the unit 3. These two are coordinated topics here. Let me share that material also. I'll post in the group right now after the class. So as I mentioned, three-phase transformer connection. Examination, all of you, essay questions. What we have not done, what is a new thing can be asked is, you can see three-phase relation between star and delta, relation between line and phase voltages for star and delta, it is done. Okay, the derivation you can see. Now, explain, you might get one more question. Explain three-phase transformer connections, not single phase. Explain three-phase transformer connection. Just now I've shared that syllabus. Okay. So how to explain that one? It is diagram. There is no theory for this topic. Okay. So show me the three-phase transformer. Sir, in near our house we are having single phase or three phase. We are having three phase only transformers. That no need to draw this diagram for your understanding. Here also you can see all the three-phase transformer contains three different windings which are displaced by an angle 120 degrees. We cannot draw this diagram. Okay. So which diagram you have to draw? Three-phase transformer connections means a three-phase transformer can be connected in a three-phase transformer has got primary and secondary. Primary can be connected in delta. Secondary can also be connected in delta. This is one first set. What is another connection? Primary is connected in star and secondary is connected in delta. Single phase transformer means we are saying directly primary winding and secondary winding. Three-phase transformer means yes, it has got primary and secondary, which can be connected in four possible combinations: delta star, delta delta, star delta. Okay, this diagram you can draw. Examination by the time you see the three-phase transformer connection. Three-phase transformer contains primary and secondary, in which the primary can be connected in case A, delta, secondary also connected in delta. Similarly, four different combinations. Okay. If you want, you can redraw this one for the essay question. Same diagram. This is the easiest one. If you want to draw once again, you can also draw. You can practice this one. Yes. For diagram only, you'll get marks. This is star to star connection, delta to delta, primary star, secondary star. Okay. So now only one point you are supposed to write. Another material I've given 2-3 lines extra. Diagram only will show the answer and simple words. So you have to remember this one. What is the use of star to star connection? So star to star connection transformer is used for high voltage. Here I have written high voltages. So whenever I require high voltage transformation, I have to connect three-phase transformer in star, primary star and secondary also star. Next, for low voltage, delta to delta. Okay, delta delta connection. For step down transformer, three-phase step down means primary should be star and secondary should be delta. Okay, three-phase step up transformer means primary should be delta and secondary should be star. Okay, so this diagram, that's enough. Three-phase transformer connections, remember only the diagram and simple theory which I am going to share in the group. Last 1 minute is there for today's class. As I got the final years and third years, they are also having the exams right now. We are busy with their revision classes. So that's why today, as CR has updated me, all classes are going on. Immediately I have scheduled. No need to worry for the BW exam. Now, any question is there? You just go on. Any question? This recording will be shared with the YouTube link after the class. Yes. Any question? Anyone? You can put any general question regarding exam. Okay, right. No question. I'm just ending. I'll share the material here. Right. Thank you.